AI that can actually do machine learning.
Really build the algorithm.
Yeah, not just participate in it, but actually building the algorithms, running the experiments, the whole 9 yards.
Wow.
We're diving into a new paper today from Openai
Okay.
about a benchmark that they created called MLE Bench.
MLE Bench.
It's MLE Bench, and it's designed to see just how good AI is getting at building the next generation of AI.
Okay, so this is AI building AI.
It seems like it. What's fascinating is
It's getting meta.
it really is.
Yeah.
What's fascinating is that OpenAI has created this benchmark as a way to objectively measure how well AI agents can handle real-world machine learning tasks.
So they're not just throwing them into the theoretical Thunderdome.
Right, we'll get there.
Okay.
But right now, think of it like a proving ground
Okay.
for AI.
Got it.
So MLE Bench, it's like a competition.
Exactly. Instead of athletes, we've got our AI agents. And instead of doing, sporting events, they are tackling things like data preparation, model training, all that nitty-gritty stuff that makes machine learning actually work.
So how do they make this a fair competition?
Right, because they can't exactly run the 100-meter dash with algorithms. That's where the standardized benchmark comes in. MLE Bench levels the playing field by providing a structured environment with clear rules and metrics.
Okay.
This allows researchers to compare different AI approaches to machine learning, engineering, apples to apples, and really track their progress.
And to make things even more interesting, they're not using, like you were saying, these theoretical problems.
Right.
They're pulling in 75 challenges straight from Kaggle.
Ah, yes. Kaggle. For those unfamiliar, Kaggle is like the online battleground of data science.
It really is.
It's a platform where anyone, from seasoned professionals to aspiring students, can compete to solve real-world problems using their data science skills.
So we're throwing these AI agents right into the deep end then.
Exactly.
But what does that mean for, someone like me who's not knee-deep in data every day? Why should I care about an AI winning or even placing in a Kaggle competition?
Well, because think about the implications. These aren't just abstract puzzles. They're challenges based on real-world data. We could be talking about anything from optimizing traffic patterns in a city to, improving disease diagnosis.
Wow.
If an AI can perform well on Kaggle, it means it has the potential to actually impact our everyday lives.
Okay, that makes a lot of sense. So how did the AI actually do in this MLE Bench competition? Spill the tea.
Right. So OpenAI's own model, unsurprisingly, emerged as kind of a front-runner here.
Okay.
It achieved the equivalent of a bronze medal in almost 17% of the competitions.
Hold on. A bronze medal. So not quite taking home the gold.
Not quite taking home the gold yet.
Okay.
But let's put that in perspective.
Okay.
Even achieving a bronze medal means that this AI is outperforming a significant portion of human data scientists on Kaggle.
That's true.
Which is a pretty big deal.
It is a pretty big deal, to put it that way. Yeah, that's kind of mind-blowing. But they weren't just looking at the final scores, though, right? The paper mentioned resource scaling and contamination.
Right.
Those sound a little ominous.
Could sound very sci-fi, don't they?
Yeah, like something out of The Matrix.
Not quite The Matrix, but important considerations nonetheless.
Okay.
So resource scaling. Resource scaling basically explores how the AI's performance changes when you give it more computing power.
Okay.
So does it kind of plateau at some point, or does its ability just keep improving?
Right.
This helps us understand the scalability and the potential of these agents.
So figuring out if there's a limit to how smart we can make these AI agents.
Exactly.
And what about contamination? That sounds like we're worried about the AI cheating somehow.
In essence, yes. Contamination refers to the risk that the AI might have been exposed to similar data during its training, which would give it, an unfair advantage.
Okay.
Think of it like studying the answers before a test, right? Ensuring fairness is crucial for, 1, building trust in these systems, and 2, knowing that they're genuinely learning and problem solving.
So it's about making sure the AI is playing by the rules and really pushing the boundaries of what's possible in machine learning, not just copying what it's already seen, which circles us back to that bronze medal.
Right.
It really makes you wonder, what happens when an AI sets its sights on gold in something as complex as machine learning engineering? I mean, are we witnessing the very beginnings of AI that can design and build the tools for its own development?
Yeah, you're getting a little shiver down your spine thinking about that.
Just a little bit.
It's exciting and a little bit unnerving, right?
Yeah.
As we continue to develop more sophisticated AI, it begs the question,
Yeah.
what does the future hold when AI is not just a tool, but a potential architect of its own evolution?
That is the question.